In Chapter 7, we're introduced to matrices. So what is a matrix? A matrix, so here's 4 examples. I showed 4 examples right here of matrices. So it's basically an array of numbers or a table of numbers. It doesn't have a header. It doesn't have, like a table would have headers on the column and on the row to say what each spot means. In a matrix, we have it defined by its position. So that way we can just focus on manipulating the numbers, similar to the way we did synthetic division instead of long division, how we just kind of kept track of the meaning of each spot, and then it took away everything but the numbers, so we could just focus on manipulating the numbers and put in that meaning back later, keeping those positions very careful. So you'll notice this position is very careful. So very important. The matrix is a rectangular array of numbers written within brackets. So here's these are my 4 specific examples, and here's a general one. And you can see if this is matrix A, we use the capital letter to say the whole matrix. Each element is a little lowercase a, and the numbers here are row and column. So this one says in row 1, column 2. So columns, you can think of a building with columns, like a hall, I don't know, like a Greek building or a doorway. And the columns are the long way. And the rows are horizontal. I don't know what I mean by long way. The columns are vertical, the rows are horizontal. Each number is an element in the matrix is called an element of the matrix. The first subscript is the row index, and the second subscript is the column index. So there's some vocabulary for us to get started. So for example, this matrix is a 4x3 matrix, and this right here, this 4x3, is the order. That's how we call size of a matrix. And you can see remember that first is the row index, so that's 1 row, 2 row, 3 row. And the next second number is the column, so that's 1 column, 2 columns. So this spot is in the 3rd row, 2nd column. All right, and this has dimensions 4x3, so that's its order. 4 rows and 3 columns. So the order of a matrix is always given by the number of rows by the number of columns. So I always think R by C. I know it's common to think 3x4 or 4x3. I don't know which one it is. So I always try to remember R by C, like, I don't know if you remember, but like the soda RC. So that's my trick to remembering that. Okay, so let's look at those 4 matrices I showed at the top when I was talking about what a matrix looks like, and think about the order of each of these. So the order, remember, is R by C. It's this size, so it's going to be something times something. So this one has 2 rows, 1, 2, and 2 columns, 1, 2. So this has 2 by 2. And remember, R first and C second. With A, it doesn't really matter since R and C are equal, but with B, we have 2 rows, 1, 2, so it's 2 by 3 columns, so that's a 2 by 3. C, we have 3 rows and 3 columns, so that's a 3 by 3. And D, we have 1 row and 4 columns. So always count rows first and columns second. So B is a 2 by 3 as opposed to E, which is similar, but this one's a 3 by 2 because that one has 3 rows, 1, 2, 3, and 2 columns. And F is similar to D, except it's a 4, instead of a 1 by 4, it's a 4 by 1 because it has 4 rows and rows comes first. And that is how we find the order of a matrix and the definition of a matrix.